Alright, this is number 35 from your text, and we're going to solve this system, and I'm going to use elimination for this one. And the reason I'm going to use elimination is because when I look and I see these coefficients, they're opposites of each other, so I know that when I add them they subtract. And you probably noticed that these are also opposites of each other, so when I subtract them they will disappear also. In fact, that's kind of a special case that's going to happen here. So we're going to solve this with elimination. So I'm ready to add them up. So when I add these up, I end up with 0x, and I also end up with 0y, and then I end up with 7. So I'm really getting, if I complete this problem algebraically, I have 0 on the left-hand side equals 7. So this is a strange case because my x has disappeared and my y's disappear. Well, if you were to graph both of these, I'm just going to do it for you here, but you could graph them with your calculator, and you would notice that I think one of them looks like this. You could solve them for y and you could graph them yourself, and the other one looks like this. And they do indeed look like parallel lines. So if you graph them and you look at them, obviously they look like parallel lines, and that should be obvious. There's no solution. But algebraically, this is what it looks like. This is what your parallel lines look like algebraically. And so when I do this problem, I think to myself, this particular algebraic statement right here, I think of this as being false. And if something is false, because 0 obviously does not equal 7, then that leads me to the conclusion that there is no solution. So that's how I remember that this is no solution. And we also notice that, let's see here, this is a system that is inconsistent, so let's go ahead and note that. Inconsistent. Alright, so that's what a no solution example looks like. Let's do another one, and this is from your text, and I believe it's number 41, and it's 2x minus y equals negative 4, and minus 4x plus 2y equals 8. We want to solve this one, and I'm going to solve this one with substitution. So I'm going to take this top one and I'm going to solve for y, and well, let's go ahead and do that in a minute. Equals negative 4. So I want to add, I can add y to both sides. Simultaneously, I'm going to add 4 to both sides. So I end up with y equals 2x plus 4. So everywhere in this equation there's a y, I'm going to substitute 2x plus 4. So let's go ahead and do that. So minus 4x plus 2, and now I'm going to put in that 2x plus 4, and this equals 8. So now I can see I just have x's in here. So distributing or multiplying out by the 2, work this out a minute, minus 4x plus 4x, well that's going to be 0x. And then we're going to have 8 equals 8. So algebraically, this is what I end up with here. And I could graph this if I want to. I'll let you go ahead and do that. But if you graph that, you're going to find there's one line, and then you're going to find your other line. When you graph two different things, you're going to have one line up here. And when we do that, we end up with a dependent system. We know we've got an infinite number of solutions. So the way I remember that is 8 equals 8 is a true statement. So that helps me remember that this is infinite solutions. Now the way that we're going to write this particular solution is the solutions for x, y are going to be written as 2x minus y equals negative 4, and that of course comes from this equation right here. Okay, In fact, you could manipulate this next equation. You could divide everything by -2, and you would find out that this equation is equivalent to the first equation. So basically they're the same equation. It's just that the second one has been multiplied by -2. So this is how we're going to represent our solutions. Okay, and then also knowing we have infinite solutions. So those are the two special cases, no solution and infinite solution. Again, when you graph them, it's pretty obvious which case you have, but when you solve them algebraically, you need to be able to recognize if you have infinite solutions or no solutions.